Hello, everyone, and welcome. Today we're going to be hearing from Alessandro, who will be covering combined GDS and Agentic AI for automatic report generation. So I'll go ahead and hand it over to you, Alessandro.
Thank you, Aidan. So, good evening for who is sitting in the APAC area. Good morning, Europe. And if you are in the US, well, thanks a lot for waiting away for so long. I'll try to make it work. So in this presentation, in this session, you will see how to combine graph analysis with agentic AI reasoning capabilities to extract relevant knowledge from a huge set of data points. In particular, what we want to do is to convert data like this from different sources and with different shapes like CSV or Excel files, SQL databases, textual document into these summaries or reports that contain not only the same information better organized, but also the result of autonomous processes that derive relevant knowledge helpful to take informed decision. And you will see how in this process, graphs play a key role, since first of all, they organize these heterogeneous data in a single source of truth. Then they provide the tools to analyze this information effectively, and also they simplify the extraction of a large set of relevant insights. After that, LLMs can take over and transform these insights and perform the last mile by revealing meaningful patterns in the data and presenting them in a clear and concise way in the form of these summaries, as you see. Having multiple heterogeneous sources is common in almost any domain. But in law enforcement, that is the domain in which we operate, this is even worse. Because law enforcement analysts are facing an information paradox. Because they have access to a huge amount of information coming from multiple sources, some structured like public registries or traffic camera sketches, and the other unstructured like witness statement, police office reports, and so on. Unfortunately, this abundance of information doesn't translate in solving cases faster. It's the opposite, actually, because it will take even more time to them to, let's say, remove noise from relevant information, unless they have frameworks and processes that allow them to organize these data properly and process them effectively. But starting from the law enforcement domain, we can generalize to broader scenarios. And so we discover that the technical problems are very common almost in any domain. Let me describe them and see if they resonate with you. So we have a lot of data silos that must be merged in a single coherent data structure to have a comprehensive view of them. The result of this process contains a lot of valuable information, but again, a lot of potential noise. So it's important not only to analyze them properly, but also have mechanisms to focus our attention on specific manageable problems. Moreover, the conversion of these insights to concrete actions require often multiple specialized experts, human experts here, to reveal complex patterns. And in the end, the outcome must be understandable and explainable, because often it involves people's lives, so we need to be careful. It looks familiar, right? And also very complex. But with the graphs and LLMs, it won't be. So let's get started. So to make this work, let's say, applicable in concrete scenarios, we use the data coming from Chicago Police Department, and specifically from this Chicago data portal. So we will use in particular the data about arrests and crimes from 2001. So we have a huge amount of real data, very close to what our customers really have. We won't speak about the ingestion process, but later there is a talk from my colleague Federica in the European session speaking how to extract data from a textual document or to extract relevant information from textual document. So if you're interested in the topic, don't miss it. By using real data, we can answer real questions. So that can help law enforcement analysts and managers fighting against organized crime. And here is a list of a few of the questions so we can answer at the end of this journey. The process is complex, so we need to split it in two major phases to make it manageable, easier to implement, and for me, easier to explain. So the first phase focuses on knowledge graph. During this phase, we construct and analyze the criminal networks and extract relevant insights out of them. The second phase takes the results of the analysis and recognize patterns, converting them in useful summaries, reports, and suggestions. Of course, the process, as often happens in these cases, can be iterated more and more times to achieve perfection, to achieve your goal. But let's see them in detail. So this is the schema we used. This is the database we constructed using not only the Chicago Police Department data sets, but also the Illinois state data set where we can find information about custody status of people or judicial sentences that we will see are very useful. But for the majority of our analysis, we will focus mostly on offenses and people, or on offenders and crimes, if you prefer. And we will see how we can extract relevant knowledge that can help analysts to have a clear picture of how to achieve, let's say, a risk assessment to control the activities in their city and take more informed decisions. So starting from the information we have, so offenders, crimes, and the connection between these, we can create a new piece of information available in not available in the original sources, the so-called co-offending network. This is a very common network used by analysts. Technically speaking, it is a monopartite network that is obtained by projecting the crimes over offenders. And in this network, basically two offenders are connected if they committed the crimes together. Despite the fact that this is a simple network to build, it holds a lot of useful information and also a lot of interesting characteristics and here you can find a list of them. But what is really relevant is that this is useful in the analysis of complex crimes committed by organized entities like gangs or mafia-like organizations. In reality, this is no more, no less than a real social network like Facebook or LinkedIn. But in this case, people are not connected because they would like to go out for a beer or they would like to create constructive work collaborations. Here, people are connected because they committed crimes together. But at the same time, we can still use all the social network analysis techniques that we know to analyze them. So before talking about that, it's important to mention that not all of the relationships are the same. So we needed a mechanism to assign a weight to this relationship. Among the different methods and options we had, we decided to use this association strength method. That is the same used for analyzing a paper co-authorship. The interesting thing about this method is that it considers not only the number of crimes committed by two people together, but also the number of crimes that each of them committed in general. And these we noticed assigned a better weight to this relationship. So now we have like a huge, let's say, criminal networks or co-offending network. What we need to do now is to start dissecting it in various communities based on how people tend to commit crimes together. There are even here different algorithms to do that. And the graph data science library provided by Neo4j contains three very good options. My favorite one is often Louvain, because it is a hierarchical clustering method that maximizes the likelihood that two nodes in the same community are connected compared with two in different groups. And it is quite computationally efficient, which means that running on these large networks will provide results quite quickly. So what we did was to run over our network, and we identified multiple independent, I'd say, communities of offenders that collaborate often together in committing crimes of various types. At this point, after this Louvain run, we have multiple communities. And now we need to identify in these communities those people that have higher relevance, considering how well they are connected with other people and where they are positioned in the community. Even here, we can use a graph data science library to compute the relevance of each person, considering, for example, PageRank and Betweenness centrality. People with a high PageRank occupy the center of the community, and they are influential since they are connected with other influent people. Because and while Betweenness centrality helps us to identify instead the so-called bridges, so those people that operate between two or more groups acting as a facilitator. Otherwise, these groups will be disconnected. These people with high PageRank and Betweenness centrality are important because if we act on them, if we arrest them, for example, we can affect the capability of the network to operate. Before moving to the next phase, I'd like to fix in your mind a few points with a very quick demo. So let me start with a simple example here. So we have two people that committed these three crimes together and two people that committed these other three crimes together. But they are not connected in the same way, because if we expand these co-offending network, we notice that these two people are connected just to each other and nobody else. So as we can imagine, if I explore their, let's say, association strength, it is 0, 1. This is a different type of network because these people are connected with other people, actually. So if we continue to expand, we can see that they are connected with many other people. So clearly, they are not as strong connected as this one. So if I look here, we can notice that the value of the association strength is half of the previous one. And in fact, if we expand the entire community and we remove this one, we see that we have that this is a way more let's say structured community. In this community, we can easily reveal who is who by using the value of the Betweenness centrality. So we can notice that this Malik person is definitely the center of the communication between multiple otherwise independent groups, and the same will reveal the PageRank. So changing it, we see that of course in this case, other people also has some importance because they are let's say lead or other subgroups, etc. So this is exactly what we have done so far. So at this point, we are ready to discuss the second phase. During this part, you will see the journey we went through. From the first attempt to the current status. I hope that this will help you to not only to understand better what we have done, but also to help you in the case in which you are in the same type of journey. So the phase 2 operates at group level. So it runs through each of the independent group. The goal is to extract, let's say, details about the group composition, how and where it operates, and what is the evolution of the group over the years. So we can answer the questions that I showed you. At the end of the first phase, as we have seen, we have all the information, the insights we need to do that. But they are organized like this picture. So we have this JSON containing generic information about the number of crimes, the type of crimes, the list of people, the list of crimes with the list of offenders, etc., etc. It's quite a lot, in particular for big groups, for a human to process. So our first attempt was to take the JSON, to instruct an LLM model with a single JSON together, with the data, a single prompt, with a JSON, and then we get the HTML. Of course, in this case, we have a single prompt that will cover the three areas of the report that we want. So one for demographic, for temporal, and geographical, but the LLM was a single one. And all the reasoning happens in one shot with all the data included in this process. What we've got from this first attempt was quite a promising generation, because the first result was actually revealing interesting patterns. And of course, this was a simple, quick and dirty test for us to implement and then to maintain. But when we went through the details of the different reports for different type of groups, we noticed that the results were quite poor, in the sense that some sentences were repeated many times, that the HTML was not always generated properly, that the ordering and the computation of several statistics was often wrong. So we moved to a second attempt. Even because fine-tuning the prompt was a nightmare, to be honest, because when we were changing something, it was difficult. So we decided to split the process in 3 independent areas. So we created literally 3 experts, by using 3 different prompts that run in parallel, actually. So we have the parallel execution running these, let's say, pieces creation independently. These are specialized prompt, as I said, and then the aggregator just put together and created the final HTML. Of course, this approach generated better results from the previous one, even in terms of the quality, and it was faster because of the parallel execution. But unfortunately, we had a lot of repetition because these 3 independent prompts tend to generate few common information all the time. And also we suffered from the same problem that we had before with the computations, with the ordering, with also with the HTML generation. So I would like to avoid you to follow the entire process, but the basic idea of the final configuration is this one. So we did a lot of changes, as you can notice, in the meantime. So first of all, we introduced a data pre-processing and validation process, where we literally control not only the quality of the JSON, but also perform some basic operation like organizing the crimes by grouping them by year, month, and by date. This avoids the LLM to have to compute it all the time. Then we introduce another step, that is the systematic analysis that computes by using Python a lot of statistics, including, of course, the average of the age or the distribution per year, together with a lot of the percentages regarding how many, let's say, male versus female composition of the group, some basic information about the top key player in the group. And again, these simplified a lot the work that the LLM had to do. These not only made better results, but also improved let's say, the speed of the entire process. And then we introduced a lot of techniques in terms of architectural patterns for these, let's say, workflows. In particular, we introduced prompt chaining. So we replaced the parallel execution with a chain of prompts. So the first one is one of the input used by the second one, and these 2 are the input of the third one. In this way, we not only improved the quality of the report for the second and the third one in particular, but also avoided repetition, because the LLM is now aware of what has been mentioned, before, and these avoid the repetitions. But also improve the quality of the final result because it has more context. Then we introduced the reflection pattern. In this case, it's a self-reflection. So we use the same LLM, but with different prompts. In this case, the reflection literally takes the result of each agent and actually evaluate it. So we wrote the prompt to have a list of criteria that have to be met. And if the report respects it, it passes to the next step. Otherwise, it comes back to the previous one with a list of critical errors and a list of improvements. And this boosted our quality by 10 times, I'd say. And then we introduced some tools. In particular, for the temporal pattern, we added the opportunity for LLM to decide to query the custody status of people to match, for example, that in a specific period we had, let's say, a reduction of an activity, maybe because the key person was in jail. And for the geographic analysis, instead, we used the nominating to translate latitude and longitude in areas of Chicago. As you can guess, this boosted our results quite heavily. Because we have better and more accurate reports. The number of insights now is always, the numbers and insights are always correct. no error in the HTML because of the reflection, and actually accessing the data helped us to have a better picture of the situation. Of course, it is even slower than before because it requires all these steps to be executed in sequence, and some of them are quite complex. And we have a more complex infrastructure to maintain more elements, more prompts, etc. While we were, let's say, improving our, architecture, we also worked to improve our prompt, and then our prompts, actually. We applied a lot of the good techniques that you will see here very quickly, but if you're interested, there is the presentation that I will share, and also the entire blog post series talking about this. But what was interesting for us was the introduction of a systematic method for, let's say, evaluating the changes that we do in the prompt, because otherwise we would perform some changes that we evaluate with a few set, and then maybe we are deteriorating the quality of others. So we introduced this LLM as a judge. That is a methodology to evaluate the quality that we will see later. But let me quickly go through a few examples of the prompt engineering techniques that we used. The first one was the role-based prompting. So we literally changed the wording of the role from you are an expert in analyzing organized criminal groups to a more precise, you are a criminologist specializing in Chicago, trained in co-offending networks and criminal social network analysis. And these helped us to frame better let's say the professional boundaries, and improved a lot, not only the final quality, but also the terminology used in the report. Another one was, of course, to fix the HTML issue. So we provided a precise structure that we were expecting from the LLM to generate, and some examples. And this, again, was definitely a useful way to improve the quality. And then for complex reasoning, and particularly for the geographical part, we use this three of thoughts technique, where we describe not only what we would like to get, but also how to get there. And again, this was a good introduction. As I mentioned, we introduced this evaluation system called LLM as a judge. That is a very common and very powerful technique to evaluate the evolution of prompt in particular. So what we did first was to identify from 10 to 20 different groups that have, let's say, a different number of crimes, a different number of offenders, a different structure internally, different number of people, etc., in terms of ages, sex, or gender, or let's say ethnicity, and we actually ran the report generation through all of this. Then we made an individual change in the prompt, and actually we divided the three elements of the analysis in single execution of the test. And then we have for each group two versions, the one before and after. And then we went through this LLM as a judge evaluation, where we instruct LLM with fixed criteria that have to be met or not, or we ask it to generate a score from 1 to 5. Then we ask it the evaluation of the two versions. We ran it 5 times, and we always inverted the order to avoid any, let's say, any bias. So this overall was our bias mitigation protocol to get better results, and so we were able to evaluate if the prompt was better or not. So I don't want to show you the full code because the code will be available soon after this presentation. But what I would like to raise here is the let's say the quality of the LangGraph, or the help that we've got from LangGraph in this process. Not only because since it is a graph-based way of describing the workflows, and we are kind of graph expert, it was a natural way to start working with this agentic AI. But I have to say that it is very powerful, because we were able to introduce almost all the patterns that you have seen in no time. And here you can see how you can just describe the nodes and edges. And this is very natural to me in particular to reason on. What is interesting that is not available, of course, in Neo4j is this conditional edge, where you can describe, in which direction to go according to some criteria. In this case, our criteria was if we have to go to the next step or to come back to the previous one. So now, very quickly, I'd like to show you the final result. In order to do that, I would like to show you another work in progress here, where we are storing all the, let's say, the paths, we went through in moving from the request to the final report. So here you see exactly what I showed you, so we started from the request, then we pass to the systematic analysis, then we go through the group analysis. We have the reflection step. In this case, the reflection judges the prompt that the result is good. So we go through the temporal analysis. In this case, the reflection says that something goes wrong. So it runs it again. Then it moved to the geographical analysis and something went well. And then, everything went well. And then we move to the final report. As you can see, we have also multiple tool calls traced here. So it will represent not only a way for us to monitor what is happening, but also it will represent a long-term memory for future development. So here is an example of the result where you can see that we have the demographic analysis summary, the criminal activities ordered in the temporal overview, and the sentencing investigation that comes from IDOC, the Illinois data set. And we have also the geographical behavior with the translation made by the nominating that helps us to identify different areas of Chicago and group them in a better way. So with this fun example, I would like you to bring home a few key concepts. So first of all, as we have seen, complex data analysis requires a methodological approach, where you have, like in our case, different steps or different phases. For each phase, you really organize not only a mechanism to process this data, but also a mechanism to evaluate the quality of the final result in a very systematic way. Then we've seen how knowledge graphs and LLMs are a good companion in this methodological approach, because they provide a powerful framework that empower both of them. So the sum is let's say more. The final result is more than the sum of the different parts. This also process, LangGraph played an important role, I have to say, because it helped us to test multiple patterns to come back very quickly. But really, it helped us to go through this test in a clear, concise way. And as you've seen from the code, it is even easy for us to understand what's going on. At the same time, on the let's say graph side, the GDS library was our best friend, because it helped us to analyze this huge amount of data in almost no time, to extract communities, to compute a PageRank for each of the groups. So it was an amazing help in the process without using external libraries and such. And what we notice is that by embracing LLMs and agentic best practices like reflection and the others that I showed you, we were able to boost our productivity and in the end optimize our results. As a last thought, I'd like to say that if you like this combination of knowledge graphs and LLM, there is our book currently available also in printing, where we shared a lot of other ideas for using and combining knowledge graphs and LLM. And with this sentence, I'd like to thank you again for listening, and I'd love to hear your questions maybe later because we are running out of time. So there is the QR code that you can use for reaching out with questions, so we will be more than happy to answer. And if you have anything specific for me, write at alessandro@graphover.com. Thanks again.